Hello students, welcome to IMS Gate Academy. In this session, I would like to do the topic of oscillators. It is also subtopic of operational amplifier. By using the op amps, I would like to do certain number of the problems. Understand now? But directly I cannot do the problems. Initially, we need to do one mathematical analysis for Wien bridge oscillator, because based upon that analysis only we can do the problems of sudden. That is why I want to do analysis for what now? Wien bridge oscillator, because based upon that you can find the questions only now. And Wien bridge oscillator is very important gate point of view. I will draw the circuit and I will start that analysis then. Wien bridge oscillator. Wien bridge oscillator. But I will draw the circuit diagram. This is V naught, R1 is connected here, this is connected to the ground. There is a resistor R2, and positive terminal is connected to the capacitance of the capacitor and also one resistor R. Here I got R and C. This is R, this is the capacitance of the capacitor. This is connected to the ground. This is C. This is nothing but Wien bridge oscillator. But what is our aim? What analysis we need to do in this Wien bridge oscillator? Even the gate or engineering service examinations, or even in the PSUs, asking questions from the what now? Wien bridge oscillator. So I said in the last class, this oscillator is used to generate the frequency in kilohertz, I said. But what feedback is given to the Wien bridge oscillators means we know positive feedback is given for any oscillators, so we know. Understand now. To produce this sustained oscillation, certain conditions I gave it in the last class. A beta must be equal to 1 and total phase shift must be what now? 0 degree or 360 degree, I said in the last class. And in this case, but how to find out the frequency and also how to find out the R2, these two are more important. Sir, why this analysis? Directly you can give the formula, you may ask the question only now. Because certain questions are asked in the gate based upon that analysis only now. Direct formula you cannot apply. Once you followed this analysis, even in the what now, problems of sudden I will give, those can be done by what now, same methodology only I can say now. Understand my point now. Anyhow, I will do now. Please watch. My aim is to find the frequency and also R2, resistance R2 in terms of R1 it comes, relation between and R1 and R2 also. How we can find this a V naught value, this voltage, even this voltage also same V naught, no doubt. This voltage I wish to take it as a VF, feedback voltage I can write. This is the feedback voltage. Even this voltage also we can say feedback voltage VF, that voltage possible. The point what you have to remember is, what is V naught if I asked, what is V naught if I asked, V naught I can get by using this relation, what It is a non-inverting operational amplifier at the top. Non-inverting operational amplifier we got. By using that non-inverting operational amplifier, I will get V naught 1 plus R2 by, it is a non-inverting op amp means we know very well 1 plus R2 by R1 into what? Vf, into Vf only. Here the point what you have to remember is the gain available from this is nothing but the A, from this operational amplifier. The gain I can get A. The A is nothing but V naught by Vf. V naught by Vf. So V naught by Vf is nothing but 1 plus R2 by R1. 1 plus R2 by R1 I can write. So I got A. So I would like to apply the Barkesian condition in the problem, A beta equal to 1. So initially I got what is A, directly I got. What about the beta value? Beta is nothing but this network I want to select. This network I want to select here now. This is the feedback network. The feedback gain is set to be beta only now. So Vf by V naught is the input of this feedback is a V naught. Output is a Vf only. I can write beta is nothing but Vf by V naught. Vf by V naught. I can write Vf by V naught only. For your understanding purpose, I say this impedance I wish to select as a Z1. This total impedance I would like to take it as a Z2 value. This network I have taken here now. Input is a V naught. This becomes one series circuit only. It doesn't flow any current this side. For ideal case, input impedance is very high. At the time it doesn't flow any current, we know very well. Understand? So this network I selected now. What is Vf I asked? Because this ratio is a beta. That beta value I want to find. Vf equal to what now? Voltage across this impedance. Vf equal to, according to voltage divider formula, V naught into what I can write? Z2 by Z1 plus Z2. Z1 plus Z2 I can write. My aim is to find the beta. Beta equal to what? Vf by V naught. So beta equal to Vf by V naught. Vf by V naught equal to how much? Z2 by Z1 plus Z2. Z2 by Z1 plus Z2 I can write. So if I know Z1 and Z2 beta I can get, then I can apply Barkesian condition. A beta equal to 1 I can apply. So how to find Z1 and Z2 is more important. Z1 I can get from the what now? This impedance I would like to get now. C is given in farads. Get capacitor reactance in S domain. 1 by Cs I can add. Wherever the capacitor you got, in S domain you convert. R plus 1 by Cs you know very well. Z1 equal to, I can write R plus 1 by Cs. R plus 1 by Cs I can write. Those two are in series. R plus 1 by Cs. If you have taken LCM, I will get 1 plus RCS divided by Cs I can write. That is Z1. Catch my point. Z1 is, these two are in series. R plus 1 by Cs. If you have taken LCM, you will get like this now. What about Z2? Z2 is nothing but these two are in parallel. Those two are in parallel. R into 1 by Cs divided by R plus 1 by Cs I can write. The same work you will do in few more questions also. Try to understand. If you have taken LCM, you will get like this now. R by 1 plus RCS I can write now. 1 plus RCS I can get now. These two are in parallel. I got Z1 and Z2 also. Now I want to find what is what beta value I want to find. I can get beta value here. Beta equal to Z2 by R by 1 plus RCS divide R by 1 plus RCS, Z1 plus Z2. Z1 is 1 plus RCS, 1 plus RCS divided by CS I can write, divide by CS plus Z1 plus Z2, R by 1 plus RCS, R by 1 plus RCS I can write, R by 1 plus RCS I can write now. So, on simplification, what I will get? R 1 plus RCS, 1 plus RCS cancel after LCM. RCS, it comes here, RCS divided by 1 plus RCS, 1 plus RCS, 1 plus RCS whole square I can get. 1 plus RCS whole square plus RCS I can get here now, plus RCS I can get now. That way we can get now. That I want to expand. Now. How we can expand that now? Now please watch. I will try to expand that value. Yes, I would like to expand this now beta value now. I will write here now. Try to understand this clearly. But I want beta. Beta equal to what I am getting here? RCS by, once again I am writing now, RCS by what I got this, no doubt, by 1 plus RCS whole square, A plus B whole square, 1 plus RCS whole square, Tirumala Reddy, good evening. 1 plus A plus B whole square, A square plus B square, I can write 1 plus RCS whole square plus 2AB, 2 RCS plus, still I got, what I got still here now? I got one more term, 2 RCS plus RCS, one more you got now, plus RCS I got. This I want to simplify. But finally, beta value I can get RCS divided by RCS whole square plus 2 RCS plus RCS is nothing but 3 RCS plus 1 I can get now. But I want to divide in the numerator and denominator by RCS. This RCS I want to divide. I will get the value like this now. If I divide it by RCS, the numerator and denominator I want to divide by RCS. RCS by RCS 1 I can get. Square and RCS cancel, still I got RCS here. RCS cancel, 3 I am getting here now. 1 by RCS I got like this now. This is beta value. But A beta equal to 1 we know very well. A beta equal to 1 means A equal to 1 by beta is possible. That's why I wish to get 1 by beta here now. I got beta. What is 1 by beta? I would like to know down here now. 1 by beta means RCS plus 3 plus 1 by RCS I can write. 1 by RCS. 1 by beta I have taken here now. Now we can apply the Barkesian condition. By using the Barkesian condition, we can get answer very easily now. How we can get? We know very well A beta must be equal to 1 as per the Barkesian condition. A equal to 1 by beta. My aim is to find out the frequency and R2 and R1 relation I want to get here now. A we got already. How much we got A? The A is nothing but 1 plus R2 by R1. 1 plus R2 by R1, A. 1 plus R2 by R1 I can write. 1 by beta is nothing but that value. RCS plus 3 plus 1 by RCS. You must follow this analysis. It is a very valuable, understand now. You will see the problems of sudden by using these conditions we know. But S in terms of the omega I want to convert it. S equal to we know very well J omega. I would like to put here now S equal to J omega plus 3. Here 1 by RC into S is nothing but the J omega. I want to eliminate the j in the denominator now. Multiply and divide by j here. Multiply and divide by j. Finally, I can get equation like this. 1 plus R2 by R1 equal to j into RC omega plus 3 j square is minus 1 minus j by RC omega. I can write. Yes, we got such a way. Now it is very simple. Comparing real part, comparing imaginary parts on both sides. You are going to get the required value. I would like to comparing real part, but I want to compare the real part on both sides. The real part is compared 1 plus R2 by R1. 1 plus R2 by R1 equal to the real part I got, that equal to 3 only. I can measure what is R2 here. R2 by R1 equal to what I can get? 3 minus 1 is nothing but 2 only now. Finally, R2 equal to what? 2 times of R1. So, in the Wien-Bridge oscillator, we are going to use R2 equal to 2 times of R1. The network is given such a way. That formula is very important, shortly useful. And next one is comparing imaginary part. Comparing imaginary part. If the imaginary part is compared, you will get the frequency only now. Comparing imaginary part means it doesn't have any imaginary part this side. I can put 0. This side I got RC omega. This side imaginary part is nothing but minus 1 by RC omega. And finally, RC omega equal to 1 by RC omega. Omega square equal to what I can get? 1 by RC square. And what is omega here? Omega equal to 1 by RC I can get here. Omega is nothing but 2 pi times of f, 2 pi f, that equal to 1 by RC. Finally, you can write frequency equal to what? 1 by 2 pi RC. Yes. This formula also you have to remember. These two formulas are very important to do the questions only now. Understand now. So, we should use R2 equal to 2R1, F equal to 1 by 2 pi RC now. By using these two relations, we are going to do the problems. The same analysis will be repeating now, you watch in the next question. I will give one of the question asked in the engineering service. I wish to give in your hand. Are you ready to do this? Are you ready to do the next question by using the same concept? You please try. I would like to give in your hand one question. By using the same concept, you can do now. Yes, I will give. But in IISc engineering service paper, ask one question. Find R2, find RF, find RF is asking, and frequency in radians per second, and frequency in radians per second. Radians per second. For sustained oscillations, for sustained oscillations, for sustained oscillations. And the network is given like this. There is an op-amp here connected with R, resistance R is connected here, resistance R. here connected with a resistance of RF, and here RF is connected here, and also one capacitor is connected here, one capacitor. And also one more resistor is connected here. One more resistor is connected, R. And this is connected to the what now? One more op amp. One more op amp here connected. There is RF and also connected with one capacitor, one more resistor R, one more op amp, and this is connected with resistor R, RF, and also capacitance of the capacitor C, and this is connected to this side. Such a way a network is given here now. This is V naught. That is the given problem. But for these questions is asking to find out the RF and also frequency in radians per second. Frequency in radians per second is nothing but, we know omega value is enough, not required F. Only omega is enough only now. But anybody can tackle this question? Anybody can do this question without my help? Any chances? How we can find the frequency and also RF? This RF value also required. You please watch. The same as last derivation only. But the students may ask a question here now on watching this problem only. Sir, can I apply the same Barkesian condition for this question? Yes, it must be applicable. This is one of the type of the what now? Oscillator only we can say. How can you say it can act as an oscillator? In the problem it is given sustained oscillations to gain. Sustained oscillations are possible only from the what now? Oscillator circuits only possible now. A beta equal to 1 is applicable when it is given sustained oscillations then now. So sustained oscillation is given 100 what now percent. This can act as a what? Oscillator only we can say now. But how we can apply the condition here now? You please watch. There is one of the network here. The gain available from this network is nothing but the A I have taken for example. One more network is given and third network also given, 1, 2, 3. All three networks of same elements only, RF, R, and C only now. The gain available from this is A means even the gain available from this circuit also we can say A only. Even from this also I can get the gain of same, that is a value only. It won't be changed. Already you have seen one Wien's bridge oscillator. There it is given one what now? Non-inverting operational amplifier and feedback is made with what now? RC network only. What you did? The gain available from the op amp into total gain means what now? Product is required now. Next the gain available from the what now? Feedback only. A into beta equal to 0. Only 3 what now? Networks we are having there now. Here 3 elements, 3 operational amplifiers we got now. What is the total loop gain here available? You please watch. The total loop gain equal to what? 1 only must. A beta equal to 1 is the total loop gain. Here also the gain available from this is A. Gain available from this A. Gain available from this A. The totally how much loop gain is available? A into A into A cube. A into A into A equal to 1 only now. That's why A cube equal to 1. I can write directly A cube equal to 1. Here beta not now A into A equal to 1. We should apply like this only now. But if I know the A value, I can substitute, I can expand, wherever the S term you got, there I can put the what no j omega, and I can compare the real part and imaginary parts, just like a last question, and I can get the what now resistance R to RF and also omega I can get now. But how we can create an equation with the real and imaginary parts is more important here now. That I will do clearly, you can understand. So what is A? At first you try to identify, try to get the what now A value from this network. So I wish to take from this op amp, this value is nothing but Z1, Z1 equal to R I have taken here now. And the total impedance of this network, this parallel network is nothing but Z2 I have taken here now. This is a Z1 value, this is a Z2 value. It is nothing but inverting operational amplifier, minus and plus, inverting op amp. In the inverting operational amplifier, you know very well, what is the gain A minus Z2 by Z1, minus Z2 by Z1. You know very well, in the operational amplifier we did already. When you want to find out the gain from the what now, inverting operational amplifier, minus R2 by R1. Wherever R2 is given, there I am using the Z2. Wherever the R1 is given, Z1 I am using here now. So I can write A is nothing but minus Z2 by Z1, I can write directly. What is Z1 and what is Z2 here more important now. Those values you can substitute in this equation. I say Z1 is nothing but, I will write here now clearly, Z1 is nothing but R itself. Z2 is nothing but, these two are in parallel. C in farads, I want capacitor reactance in S domain, 1 by Cs I can write now, 1 by Cs. RF parallel to 1 by Cs. I can write RF into 1 by Cs divided by RF plus what? 1 by Cs I can write. RF plus 1 by Cs I can write. I would like to simplify this Z2 value now. How I can simplify? Z2 equal to RF by 1 plus RF into Cs I can write now. RF into Cs I can get now. RF by R1 plus RF into Cs I can write. So these two values more important to get the A value now. But A cube I want, here I want to substitute here now. I can write here now. Otherwise you can write now. A equal to how much you write please? Write A. A is nothing but minus Z2 by Z1 minus Z2 is nothing but this RF by 1 plus RF into Cs. This question asked in the what now? Engineering service only now. RF by 1 plus RF Cs divided by Z1. Z1 is nothing but R. Z1 is nothing but R. The finally this is nothing but minus RF by R into 1 plus RF Cs I can get. Yes, that I am getting here now. That is A value minus RF by R, Z2 by Z1 is a R into that value now. But I can write A cube equal to 1 is given. I will write in the next page best now, understand. I will use now. A cube equal to 1 I gave it. I am getting the total loop gain is nothing but A cube equal to 1. What is A? We got A is nothing but minus RF by R into what? RF by R into 1 plus RF Cs. 1 plus RF into Cs. Is it right? Once again I am writing RF by 1 plus RF Cs into R. 1 plus RF into Cs. That is nothing but A cube. This is the A value. A cube equal to 1. I have taken here now. There what I want to do, you please watch once again. But I want to get the equation in terms of, but I want to get the equation with real and imaginary parts only, I said now. How we can get minus 1 cube minus R minus 1 cube is nothing but minus only here now. RF by R whole cube I can get here now. RF by R whole cube. This one I cross multiplied 1 into this with power 3. 1 plus RF Cs whole cube I can write. Just I cross multiplied with power 3 only now. Then expand the whole function. After expansion, you will get in terms of the S, put S equal to j omega, comparing real part and imaginary part, you will get answer. It's not a tough question now. It's a very simple if you made the practice. I can write this in this way, minus RF by R whole cube, A plus B whole cube. You know very well from the algebra. What is the formula? A cube plus B cube RFCS whole cube, A cube plus B cube plus 3A square B, A square is a 1, A square B means RFCS plus 3AB square, 3 into A means 1, B square is nothing but RFCS whole square, RFCS whole square, 3AB square. Such a way I can expand now. And finally, how I can get this equation now? Can I simplify any more extent now? Yes, we got this like this now. Is it not now? Any simplification is possible here now? I can't simplify anymore. S equal to j omega I will put now. That is best. Minus RF by R whole cube, that equal to 1 plus S equal to j omega. J square is a minus 1. 1 j square is a minus 1. Minus into plus minus, 1 j still left. RF into C omega whole cube I can get here now. Plus S equal to j omega, j into 3 into RF into C into omega I can get here now. C into omega. Here S equal to j omega, j square is a minus 1, 3 RF C omega whole square I can get now. Yes, finally equation is formed such a way. I can get the equation now. I can get the what now? Omega and RF value. Comparing real parts. I would like to compare the real part. Comparing real part. The real part is compared what I can get minus RF by R minus RF by R whole cube, that equal to this side what real part I can get 1 minus this value, 1 minus that value possible. That is the real part I got. I can write 1 minus 3 RF C omega whole square. This is the real part I am getting here now. If I want to get the RF value, this value is more important. How I can get that value? Please watch. I wish to compare here now. Comparing imaginary part here now. If the imaginary part is compared, what I can get? This side I don't have any imaginary part. Directly I can put 0 this side. What imaginary part you got this side? Coefficient of j minus of RF C omega whole cube I got. Here I got coefficient of j that I can put plus 3 RF C omega I can write now. We don't have any more imaginary part. I can cancel one RF C omega, RF C omega, RF C omega. On time it is cancelled, still left. And finally what I am getting now, RF C omega whole square equal to what? 3 is possible. RF C omega whole square equal to I am getting 3 value now. Sir, why we got this value means there I can substitute RF C omega whole square equal to what? 3 I can write now. So that value I want to write here now. Please watch what happens. Minus RF by R whole cube, that equal to how much it is possible? That equal to what? 1 minus 3 into what? 3. 3 into this value 3. 3 into 3, 9 is possible. 1 minus 9 is nothing but the minus 8. Minus 8 is nothing but the minus 2 cube. On both sides this minus and minus I can cancel, and power 3 and 3 I can cancel now. I can cancel directly. If I cancel, finally what I can get here now? RF equal to I can get, RF equal to what I can get? 2R is possible. RF equal to 2R is possible. Yes, I am getting RF value. That is a 2R only now. In that way we can get answer only now. I am getting this much value. RF equal to 2R is possible. Now what about the what now? Omega value here now. Omega I can get like this. RF C omega, that equal to √3 is possible here. My aim is to find the omega value. Omega equal to what I can write? Root 3 by RF into C. RF into C. What is RF? Already we got that value. We can substitute RF equal to 2R. Root 3 by 2RC I can write now. Yes. This is the required result only now. Omega in radians per second now. Such a way we can tackle this question now. Understand now. Yes, I hope you followed this question now. And I want to give one more question. Direct formula I will apply the next question now. The next question. The next question is, just wait, I will give now, I am giving now. Find R2, next problem. But here no analysis, directly formula you can apply for this question now. Sometimes you will get the what now questions, direct application of the formula. Sometimes analysis is required. Find R2 and frequency. R2 and frequency. And R2 and frequency of oscillations. Frequency of oscillations. Frequency of oscillations for the given network. For the given network. The network is given like this now. There is an op-amp, operational amplifier is given here. V0 is taken from here, and here R1 equal to 5K, here connected with R1 equal to 5K. Otherwise you can put, okay, this R1 equal to 5K is connected here. This is connected to the ground. Here connected with a resistance R2. This is connected with resistance R2. And this positive terminal is connected with a capacitance of the capacitor, that is C equal to 2 microfarads. 2 microfarads. And also given R equal to 6K. R is given with 6K. And this side R and C values are connected in parallel. This is connected to the ground. The R is nothing but 6K here. The C is connected with the 2 microfarads. Yes, by using this network, you need to calculate the resistance of R2 and also is asking to find the frequency of oscillations. Those two are more important here. Anybody can do this question? Anybody? Will you get answer for this question? How do you get answer? But I will give you time, you please complete. In 2 minutes you can complete. Directly you can apply the formula. Directly you can apply the formula to get answer. But you please tell me what is the name of this network. The given circuit is nothing but the Wien's bridge oscillator. It is a Wien's bridge oscillator. R1 and R2 here connected with RC values only. But the students may get one more doubt also. Sir, R and C values we are connecting equal, sir. Is it possible to get the problems with different values. One source in the gate paper. One is a R, one is a 2C, this is a C, this is a R, it is given like this now. Different values also given now. If it is given different values, you will see in the next class the problem. In the next class, I will do this problem also, then understand now. But anyhow, here, how to find the R2 here now? We know very well. The relation between R1 and R2 I gave already. It's a Wien bridge oscillator. Given circuit is, I can write. Given circuit is Wien bridge oscillator. Wien bridge oscillator, no doubt. In the Wien bridge oscillator, you know very well, A equal to, we know, what is A? Directly you can find R2 equal to, we know formula, 2 times of R1. R2 equal to 2 times of R1, you know very well. That formula directly, I derived already, just now I derived. R2 equal to 2 times of R1, I derived, directly you can write 2 times of R1 only. But R1 is nothing but 5K, 2 into 5K, and I can get 10K, resistance is possible. Yes, we are getting R2 equal to 10K, we are getting 10K only. And what about the frequency of oscillation? For the Wien bridge oscillator, just now I derived the frequency F equal to 1 by 2 pi RC. By using that formula, you can get directly frequency of oscillations. So, frequency of oscillations can be determined by 1 by 2 pi RC. Just now I derived. So, thereby substituted values 1 by 2 pi into R value given as a 6K, and C value is given as a what? 2 into 10 power minus 3, 2 into 10 power minus 6, sorry. And finally, frequency of oscillations generated equal to 1 by, how much it is possible? 6 into 2, 12, 12 into 2, 24 pi, 24 pi, 10 power minus 10 power 3 into 10 power minus 6, 10 power minus 3. 10 power minus 3 when goes to numerator, 10 power 3 is mostly possible. Yes, that much frequency in hertz you will get only now. That much hertz. So, 1 by 24 pi kilohertz is mostly possible from this problem, I can say. Just you use the calculator, you will get answer. 2 into 6, 12, 12 into 2, 24 pi I have taken. 10 power 3 when goes to numerator, I got that much hertz. If you want to write still easily now, F equal to 1 by 24 pi kilohertz, I can write. This is answer. That way we can do the question. I think you followed. And I want to give one more question. You please try this without my help. Without my help, you please complete. Yes, I will give next question. But I want to give one more question by using oscillators. Yes, so please try this. Find R2. Find R2. Find R2 for sustained oscillations. For sustained oscillations. For sustained oscillations. The network is given like this. There is an op amp. This is connected to the V0 and here connected with R1. This is with R1. This is connected to the ground. R2 is connected this side. Here connected with R2. And the feedback circuit is given like this. One box is connected like this. Their given values 1 by 6 at an angle of 0 degree. Such a way network is given here now. Is asking to find the resistance R2. Can you complete this question without my help? Any student can give answer for this question? I want to give in your hand. You please try this. You please try this question without my help. Without my help. Anybody? Anybody can tackle. The next section you will see still good questions from the oscillators. Hartley and Colpitts and RC phase shift and also different models. You will see. But this is nothing but in the problem it is not given what feedback network is existing here now. What feedback network is existing here, it is not specified. But is it an oscillator or not? To know only one point here given. Sustained oscillations specified in the problem. The sustained oscillations are specified in the problem. You can say this network can act as a oscillator only. This can act as an oscillator only now. In that case, we can use A beta equal to 1. Barkesian condition is applicable here now. But in this problem, please watch. Please watch. This is nothing but non-inverting operational amplifier. It is nothing but non-inverting operational amplifier. From the non-inverting operational amplifier, I can get the gain. Gain is nothing but V0 by this feedback voltage only. The gain. From the non-inverting operational amplifier, you know the formula 1 plus R2 by R1. 1 plus R2 by R1. Yes, I am getting the gain A. In the feedback network directly given, what value given? This is beta value, 1 by 6. The phase shift is 0 is given here now. We want only beta value, not required any phase shift. 0 phase shift is possible here. Anyhow, beta is given 1 by 6, given in the problem. And you can apply Barkesian condition. What condition? A beta equal to 1. If this network is acting as a oscillator, you can apply Barkesian condition. A beta equal to 1 applicable. Value not given, sir. R1 value is not given, sir. Yes. Final answer you will get R2 in terms of R1 only. In terms of R1 only now. That's one of the gate question only now. Answer it comes in terms of R1. Did you understand, Siva? Did you understand or not? R1 is not given. If R1 is given, constant value is available. Otherwise, you will get what now? In terms of R1 only now. Not given only. Yes, we can try. But here the A is nothing but 1 plus R2 by R1. 1 plus R2 by R1. I can write. Beta is nothing but 1 by 6. Beta equal to 1 by 6. That equal to 1. We know very well. And I can give here 1 plus R2 by R1. That equal to 6 into 1, 6. So R2 by R1 equal to how much? R2 by R1 equal to 6 minus 1 is a 5. Finally, R2 equal to what? 5 R1 is possible. Answer is 5 R1. But in the gate paper, it is given options also. I didn't give options here now. But anyhow, answer is 5 R1 is the right option. Understand now? Such a way we can tackle the question. Yes, I want to give one more question. I want to give one more question. You please try this problem without my help. One good problem I will give in your hand. You please try this one. You please try this question without my help. I'll see how many students can do this question from the oscillators. Find Rx is asking to find Rx. R suffix x. Find Rx for sustained oscillations. Sustained oscillations When you are given sustained oscillations, the given network can act as a oscillator only now. Oscillations. Here the network is given like this. There is an op amp minus and plus. Here I can get the V0 value. This is connected with 1K resistor. 1K resistor connected to the ground. And here 9K resistor is connected here. There is one 9K resistor. And here this positive terminal is connected with one resistor like this. You try to use your brain and give answer. This is 0.5K. 0.5K. Here connected with inductor. That inductor value is given L. Here connected with one capacitor. One capacitor also given C. There is a resistor that is nothing but Rx. This is connected to this side. In that way, network was given now. Can you find is asking to generate the sustained oscillations, we need to calculate Rx value. Anybody can find what is Rx from the given network? You please try this question. I want to wait for some time. You please try this. Your work is required. L value not given, C value not given, L and C here given only now. Anybody? Anybody can do this? Work is yours initially. But in this problem, this can act as an oscillator, you know very well. I will give the idea, you try to do the now. This node voltage is nothing but the VF, feedback voltage, no doubt. This node voltage is nothing but the VF. Even this voltage also same VF. So, sustained oscillations means what you can apply, Barkesian condition is applicable. A beta equal to 1 is applicable. A I can get from the what now? Non-inverting operational amplifier. A equal to 1 plus R2 by R1. Find it directly. What about Rx? Beta is nothing but, you know very well, output voltage by input voltage. For this network, input is V0, output is a VF. VF by V0. That value possible. VF by V0 you are getting means you should apply what? You should find what is VF by V0. VF by V0 is required means nodal analysis is applicable here now. In this network, you try to apply the nodal analysis. When you are applying the nodal analysis, VF by V0 you will get in terms of Rx. In terms of Rx or something you know. And finally, what now? A beta equal to 1 you apply, comparing the what now? Real part and imaginary part, you will get the Rx value directly. That is more important. Can you complete this question? Today, I will give this question in your hand. You try. If you are not getting, tomorrow I will do this question and the same type of questions I will give few more in the next class. Okay, then I think you followed so far. Thank you.